In this video, we're going back to the Golden Age. We are looking at the history of one of America's long-lost aircraft manufacturers, which used to regularly compete with the likes of Boeing and create many of history's most iconic aircraft. The aircraft we will be meeting is America's second jet airliner, the Douglas DC-8, one of the most famous products of the former leader of the aviation industry. This four-engine jet airliner developed in the 1950s was one of the main passenger aircraft of its time. Let's begin with the first jet airliners. After the World War II, the aviation industry, like much of the world, changed. The world was becoming more accessible, and technology had advanced. The competition between aviation giants was becoming more fierce. Boeing, which created the legendary bombers, had made huge progress in the field of military, armed aviation. But in the civilian world, they had almost nothing to offer. Their struggle liners and strata cruisers could hardly compete with the leaders in civilian aviation. Douglas, however, had created an industry favorite, the DC-6. Douglas had produced hundreds, some of which still fly today. Additionally, Lockheed produced the Constellation, which eventually became a real legend. Convair wasn't lagging behind with their CV-240 family. The CV-240 family was produced in hundreds and was loved by the industry. However, great success in the field of piston aircraft played a cruel joke with these companies. Having vast experience in creating such planes as well as the manufacturing and maintenance infrastructure, did not allow them to change quickly in the new circumstances. The 1940s brought about real innovation. The first sparks of this revolution in the civilian sector were the appearance of the turboprop Vickers by Count in 1948 and the de Havilland Comet, the first pressurized commercial jet, in 1949. Nevertheless, the American manufacturers were still skeptical about this direction. The turbine engines at that time were terribly unreliable in comparison to piston engines. Regardless, it was impossible to completely ignore this new trend. Companies began to direct their research towards turboprop engines, hoping that they could change the power plants with minimal risk, in keeping the general design of propeller aircraft, whilst Convair was lagging as its priorities laid in their military programs, such as the recently created and extremely complex B-36 Peacemaker bomber. Douglas, however, was reluctant to leave piston engines behind as they were still their favorite, and in 1953 they released the DC-7 to the market. At this time, Boeing continued to actively develop jet aircraft technology. Having created the B-47 and B-52, the company gained invaluable experience in developing large jet planes. The turning point for Boeing was the U.S. Air Force order for a new generation of aerial tankers. The piston KC-97 Strata freighter could not work effectively with jet aircraft, as it was too slow for jet aircraft. The implementation of the military needs with the Boeing KC-135 Stratotanker project, which was created with a clear aim at the potential civilian implication. It was obvious that Boeing had both the technology and the desire to enter the modern civilian aviation market. Douglas dominated the market and they weren't going to give up their place to competitors. The company began working on jet aircraft in 1952. Their aim was to create an 80-seat four-engine airliner, capable of flying 3,000 to 4,000 miles, nearly 4,000 to 6,000 kilometers. Their paths came across with Boeing during the same tender for the tanker creation. However, while Boeing initially created the tanker, planning to build a civilian modification afterwards, Douglas, on the contrary, wanted to make a tanker based on a civilian airliner. Boeing had the technical advantage and in turn extensive experience in working with the Strategic Air Command of the U.S. Air Force. The expectation was that the military would divide the order and give it to several companies, as it had done so many times before. However, the whole contract was awarded to Boeing. Douglas could only continue to work on the civilian version. Douglas started a series of consultations with airlines and the DC-8 project was officially announced in 1955, despite the rapid development of the competing Boeing 707 program. The work was carried out according to plan. Douglas was still the industry leader and the delay to adopting turbine engines was not considered critical. Although both companies were increasing the pace of work, The British were leaders in this field, and there was information that USSR also got a jet aircraft of their own. The American press began to question their aviation manufacturers. However, at the same time, Douglas retained skepticism regarding the choice of jet engines. The turboprop aircraft created at the time proved to be excellent. Vickers Viscount was supplied in large quantities, and Bristol Britannia and Lockheed Electra looked very promising. The first jet aircraft overseas caused a sensation, but all was not as it seemed. De Havilland was struggling with the Comet disasters, and the operation of the Tu-104 caused many difficulties. Additionally, the French jet Caravelle, which took off in 1955, was inferior to Comet in several specifications. Finally, the ambition of airlines played to the benefit of the new aircraft generation. On one hand, the operation of jet aircraft was still difficult and risky, but on the other hand, these revolutionary machines created an image of the airline's incredible advancement. Having such a plane on the ramp was considered modern, trendy, and stylish. In the United States, Juan Terry Tripp, founder of Pan American, became the main catalyst of the image game in 1955. Pan American Airline made an unprecedented step. It signed contracts for 20 Boeing 707 and 25 DC-8. This act provoked an explosive demand for jet-powered aircraft from the entire industry. Immediately, more than a dozen other large operators also placed orders for future flagships by 1958. Douglas had a portfolio of orders for 133 aircraft and Boeing for 154. At the time, these numbers were huge. The original DC-8 production site was supposed to be the main Douglas plant in Santa Monica, California, but this factory was geared for the piston planes, and for the new larger jet aircraft the local airport was too small. The local authorities did not allow expansions to accommodate the increased size. Besides, it probably wouldn't be for the best to have the unverified 4-engine giant jet plane flying through the city. Therefore, production was moved to Long Beach. The basic DC-8 was the Series 10 model. The aircraft received the fuselage almost 151 feet, or 46 meters long, and the cabin capacity reached 177 passengers in the standard layout of 3+3 economy class, and 2+2 business class. However, airlines often played with these schemes, making them sometimes not standard. The crew was made up of 3 people, 2 pilots and a flight engineer, due to the requirements of the FAA. The cockpit of the DC-8 and Boeing 707 were very similar to one another. Although, the DC-8 had an unusual air conditioning system. The pressurization was performed through compressors with air intakes located in the front fuselage section. The choice of powerplant was also small. 4 Pratt & Whitney JT3C turbojet engines were placed under the wing with the takeoff mass of 273,000 pounds or 124 tons. The airliner had a flight range of almost 3,800 nautical miles, or 7,000 kilometers. The ability to fly across the Atlantic was critical. Though the first series was more likely built for domestic flights, the first plane passed the rollout ceremony on April 9, 1958, and made its maiden flight on May 30. A few months later, Boeing confirmed its primacy by starting deliveries of the first 707 airliners to customers. Douglas was performing the flight test as fast as they could. 10 aircraft took part in the tests at once, and the model passed the certification in the summer of 1959. However, this speed came at a price. The first aircraft were slower than planned, and some of the mechanization was not efficient enough. Deliveries began in autumn of 1959 with the distribution of the first aircraft to Delta Airlines and United Airlines during the following year. Douglas reached the production rate of 8 airliners per month and continued to develop the line. Soon a Series 20 model appeared, with more powerful JT4A engines. Finally, a Series 30 airliner was created for fully transcontinental traffic. This plane was heavier due to the increased fuel capacity. Its range reached 4,000 miles or 7,400 kilometers, which made the transatlantic flights optimal. Douglas focused on improving aerodynamics and increasing the efficiency of the engines, culminating in the Series 40. Its airframe and mechanization became much more efficient, and new Rolls-Royce Conway engines were installed. The finale of the speed increasement was reached in 1961, in a rather crazy by modern standards, but impressive way. During one of the test flights, the plane was raised to a ceiling height and then thrown into a controlled dive with a maximum engine thrust. In 16 seconds of this madness, the aircraft accelerated to a speed of about Mach 1.012. This test made the Douglas DC-8 Airliner the world's first civilian aircraft to break the sound barrier, and it was done not only by reckless testers but also by the PR management. In addition to this, advertising was also the fact that the DC-8 was accompanied by the F-104 Starfighter, one of the fastest planes of the time, piloted by the first men to break the sound barrier in 1947, a true living legend, Chuck Yeager. The DC-8's advertising was excellent. However, specifically, the Series 40 was not a success in the United States. American operators didn't want to buy a plane with British engines, and the Pratt & Whitney JT3D developed shortly after were very good, which made it preferable for further upgrades, and the creation of the Series 50 airliners in 1961. These planes had several versions with different ranges, and the first to receive the cargo version, which had a certain popularity, that they were unable to get rid of the main drawback. The differing in takeoff masses and fuel capacity. The Douglas in fact had the same airframes with the same passenger capacity, which limited the diversity of the park, while the competitors from Seattle were offering their planes in different versions. This led to the fact that some airlines refused the DC-8 in favor of Boeing and Convair models. By the mid-1960s, demand began to drop, and in 1965 Douglas announced the DC-8 modification with more radical solutions. The Super 60 series airliners were made up of three main modifications. The DC-8 Series 61 with a stretched fuselage with capacity of 259 passengers, the largest volume among all the passenger aircraft until the appearance of the Boeing 747. The DC-8 Series 62 was the long-range version. Its fuselage was shortened due to improvements in systems and a larger fuel capacity. It had a range of 5,200 miles or 9,600 kilometers. The DC-8 Series 63 was the third and final model, releasing in 1968. The 63 series received a Model 61 fuselage, innovations of Model 62, and updated engines. The plane was the most complex and heavy, but with a capacity of 259 passengers, it flew on a range of 4,000 miles or 7,400 kilometers. These projects became a fully realized family and gave airlines the long-awaited flexibility, creating a second berth for the program and making it possible to return the interest of many customers. But as time went on and demands grew, another problem, the loud engines, became evident in large city airports. Residents began complaining. Eventually, New York developed restrictions on the noise level in areas of their airports, leading to operators having to decrease the payloads and the amount of fuel to reduce noise during takeoffs and landings. Initially, it only concerned New York, but by the 1970s restrictions began to spread around the world, which became a real headache for the airlines. Their frustration was heard in 1975, when Douglas along with General Electric began to work on updating the engines. The result of their work with the modified airframe, and the installation of the new CFM56 engines, which would later be used for thousands of other aircraft, updated family were rebranded the DC-8 Super 70 Model 71, 72, and 73. They technically became the re-engined versions of the Model 61, 62, and 63. The Super 70 series was a great success for the company. The noise level fell by 70%. The DC-8 went from one of loudest into the quietest. Furthermore, the new engines were 23% more economical, reducing fuel costs and increasing flight range. Over the lifespan of the DC-8, 556 aircraft were sold, 146 aviation incidents occurred, of which 83 were disasters resulting in the death of over 2,200 people. This indicator, although unfortunate, is common in first-generation airliners. The DC-8 and Boeing 707 competition lasted throughout their lives, but ironically prematurization of the CFM56, one of the most popular modern engines, increased the longevity. If the 707 remained in the military, the DC-8 could have been one of the most used commercial aircraft in history. The DC-8 continued to be operated on commercial routes. About 200 planes were still flying in the early days of the 21st century, despite the fact that they were no longer produced since 1972. In 2018, approximately more than a dozen DC-8 cargo versions remained in operation, and their service is coming to an end. In conclusion, the Douglas DC-8 slowly leaves the sky and occupies a worthy place among the legends of aviation. As of 2020, there are only 2 Douglas DC-8s in commercial operation. Thank you for sticking around for so long. Please, subscribe to the channel and like the video, as it will help the channel to grow faster and will motivate me to make more videos like this for you.